Hello guys, welcome to Ramta Solutions. Welcome to your lesson on trigonometry. Today we are defining trig ratios. So at the end of this video, you will know how to use this mnemonic SOHCAHTOA. So without any waste of time, let's get into it. The first trigonometric ratios that you come across, and you also see them on your calculator, they are sine, which is also symbolized as sine, and you also have one called cosine, which on your calculator you will see as cos, and lastly you have tangent, which you represent as tan. When we use this, we use them referring to a right-angled triangle. Let me just draw a right-angled triangle and use angle theta. So yeah, it's a right-angled triangle. So this side here, we refer to it as the opposite side. Right? And this side here, we refer to it as the adjacent. Right? The side that the angle is lying on is called the adjacent side. And of course, the side that is opposite the right angle is the hypotenuse. Okay, is the hypotenuse. Okay, it's the hypotenuse. So let me change colors. So when we talk about the sine, we are saying that sine, in this case, in this right angle triangle, we're using angle theta. So sine theta will be opposite. It's the opposite side over the hypotenuse. Okay? It's the opposite side over the hypotenuse. Now, when we talk the cosine, cos theta is the adjacent side. It's the adjacent side over the hypotenuse. Lastly, we look at the tangent. So tan theta will be the opposite side, over the adjacent side. Okay, over the adjacent side. Okay, over the adjacent side. Okay, so note, this only applies to right-angled triangles. Okay, it only applies to right-angled triangles. So to help you remember these definitions, you will use the mnemonic that I spoke about earlier, SOHCAHTOA. Right? This will help you remember these definitions. So what is SOHCAHTOA? Sine is opposite over hypotenuse. What is cosine? Cosine is adjacent over hypotenuse. And what is tangent? Tangent is opposite over adjacent. Okay, so you say these relative to whatever angle that you are looking at. Okay, you say this relative to whatever angle that you are looking at. I'm going to copy this triangle and draw another one because I want to show you something. Okay, there's something that I want to show you. So let me do this. I'm gonna copy it. So all right, now let me introduce another triangle here. Okay, The font size is too big. I'm introducing another triangle here. It's still a right-angled triangle. I'm going to call this angle here alpha. Now, as usual, the hypotenuse is opposite the right angle. Okay? The hypotenuse is opposite the right angle. Okay? So, now which side is referred to as the opposite? One that's opposite angle alpha is this one here. So this one here will be the one referred to as the opposite side, whereas this one here is the adjacent. Now, I am showing you this because I want you to not cram that it's always like this. It can also be like this. Okay? It can also be like this. So, for example, we have said sine is always opposite over hypotenuse. But look at this one here. It's still the same. Then what if I was saying to you, look for, because this is 90, this is alpha, sum of angles of a triangle are theta, sum of angles of a triangle is 180. This would be 90 degrees minus theta. Now the question I should ask now is this. What is sine 90 degrees minus theta? What would it be? It would be adjacent over hypotenuse. Can you see that? It would be adjacent over hypotenuse in this case, but please, you will see the application of this example later. What you need to know is to know that one, the opposite side, here we didn't call it opposite, we called it adjacent because we started with this triangle here. So it was adjacent over opposite, or adjacent, opposite, and hypotenuse. But the side that is opposite 90 minus theta is this one here. What is the side that is the hypotenuse? It's still the same. What is the side that is adjacent? The side that is adjacent is this one here, and we called it opposite. Okay, but traditionally you can say this is what is happening, but you're going to see this example. When we have it like this, we can leave it in this way. Okay, but if I were to ask you to find sine 90 minus theta, you will say this, because at that time when you get this question, you will have been given the values of these sides. Okay, you will have been given the values of these sides. So coming to this one here, sine is still opposite over hypotenuse. Do you see this time around I have called this side opposite and this side adjacent? Can you see that? Do not confuse these things. Sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, and tangent is still opposite over adjacent. What you need to know is that we define these things relative to the angles. Okay? We define these things relative to the angles. Okay? Perfect. Now, let's try this example here. Going for examples now. Right. So, our example, let's say we are given this one here. It's 23 degrees. It's a right angle triangle. This side is S. This is R. This is Q. Now, I'm asking you, what is 1? Cos theta 2 sine theta 3 tan theta. So, as response, what is sine cos theta? Remember, SOHCAHTOA, right? SOHCAHTOA. Sine cosine, here is it, is adjacent over hypotenuse. All right? Allow me to just say adjacent, just like this, and hypotenuse, just like that. Right? Now, which side is adjacent to 23 degrees? I'm sorry, I should have said cos 23. Let me fix that. Let me say cos 23. Let me say cos 23 degrees, sine 23 degrees, and tan 23 degrees. The side that is adjacent to 23 degrees is this one here, and we call it Q. The one that is the hypotenuse. Remember, hypotenuse is always opposite the right angle. It's this side here, which we called R. Right? Perfect. Now, let's look at sine 23. Sine is opposite over hypotenuse. So which side is opposite the 23 degrees? It's this one here, and we called it S. What is the hypotenuse? It was R. Now, let's then look at tan 23. We said tangent is opposite over adjacent. So it's opposite over adjacent, right? So what is the opposite side? We called it S, and the adjacent side, it's Q, right? It's Q. Do you guys see that? So this is one example, right? This is one example we can use. Now, let's try another example. I will call it example 1. Let's try another example. We will call it example 2. Now, with example 2, we have this. This is angle beta. This length is 34 units. This is 16 units. And this is 30 units. Now, we will say determine cos beta, and then determine sine beta, or maybe let me also add alpha here. Determine cos beta, determine sine beta, determine tan alpha, and here determine cos alpha. Now, let's look at it. What is cosine? Cosine is opposite, remember, SOHCAHTOA. What is cosine? Cosine is adjacent over hypotenuse. Now we're looking at cosine of beta. The side that is adjacent to beta, 90 degrees. The sine that is adjacent to beta is this one here, which is 16, isn't it? So remember, it's adjacent. Let me write the formula maybe, so I can remind you. Adjacent over hypotenuse. What is that? Adjacent was 16. What is the hypotenuse? The side opposite the 90 degrees is 34. Do I have to round it off? Yes, I think I should. So this looks like it's 8 over 17. Is that so? Yes, it's 8 over 17. Now, let's look for sine beta. Remember, sine is opposite over hypotenuse. Which side is opposite side angle beta? It's this one here, which is 30 units. What is the hypotenuse? Obviously, it's 34. Now, this looks like it's 15 over 17. All right, this one is 15 over 17. Right? Perfect. Now, proceeding, we go into tan alpha. This is alpha. If you recall, tangent was opposite over adjacent. Now we're looking at angle alpha. One that is opposite alpha is this one here. It's opposite. So, what is it? Tan, we said it's opposite over adjacent, which is opposite is 16. Which one is adjacent? Adjacent is this one here. The one that's adjacent to alpha, please note, one that's adjacent to alpha is this one here, which is 30 units. Therefore, it says to me, this must be, if I simplify it, it looks like 8 over 15. Yes, this is 8 over 15. Right? Remember what I had said. These are relative to the angles. Right? Perfect. Lastly, looking at cos alpha. Again, cosine is adjacent over hypotenuse. And what is that? Here is alpha. Which side is adjacent to alpha? It's this one here, which is 30 units long. And which one is the hypotenuse? It doesn't change. It's 34. So this simplifies to 15 over 17. So this is how you use SOHCAHTOA, and this is how you are defining your ratios. Okay, so this is it, guys. I hope you guys enjoyed this, and please do not forget to subscribe. So see you next time, and bye bye.